Hey guys, so in this video I'm going to finish up Unit 1's quick review. So for number 3, if we started with the parent function y equals x squared, and we threw out a negative out front, just like we did in what was given for number 3, this would mean that we would have to reflect over the x-axis from the parent function. Then, if we threw out a number that was greater than 1 out front, so let's say we multiplied it by 4. So this would mean that we would have to stretch the parent function by 2. Then if we had something on the inside, like positive 2, so let's say if we had like plus 5, that means that we would have to move left 2. So a way to remember if it's left 2 or right 2 is because if we're on the inside, we're going to do the opposite of what the sign says. Well, on the inside, it also affects the x's. So on the x-axis, looking at number 1, so I can have a coordinate plane, typically positive is on the right side, and negatives would be on the left. So according to the positive sign, we should be moving to the right. But we're actually going to do the opposite of it because it's on the inside. Now, for our last thing that is thrown out there, what if we had negative 4? Or similar, let's say negative 2. Negative 4 on the outside affects the y's. So if we're looking at the y-axis, which is that up and down axis, and we're going to be obedient because it's on the outside of the parentheses, negative numbers are down. So we're going to be moving down. So those would be the 4 transformations for number 3. Now, for number 4, a lot of people overthought it. It's okay. What is the vertex of this pinkish, beigeish, whatever looking graph? It is 0, 0. It is the point where the graph changes direction. It's going down, then it all of a sudden is going up. So that is the point that it changes direction. What is the point of the teal graph? The vertex is at 2, negative 1. Going down, then all of a sudden going up. So that is the vertex. So if we have the 2 vertexes of these 2 graphs, we are told how are they being transformed? How is it going from one to another? Well, to get from this point to this point, we went down 1, and to the right 1, 2. So we're going to take our parent function. We're going to keep y equals. Inside of the parentheses affects the x's. So which one, the down one or the right 2 affect the x's? The right 2. On the inside, are we obedient or disobedient? Disobedient. So if we went right 2, which typically in our minds would be plus 2, we're actually going to have to do the opposite in our equation. Then, if the right 2 was affecting the x's and on the inside, down 1 is actually going to be on the outside because it affects the y's. So outside is obedient, so we're going to do subtract 1. And that is how you would create an equation for these transformations for number 4. Okay. And then lastly, for Unit 1's quick review, number 5. A ball is thrown into the air with an initial upward velocity of 48 feet per second. If height h in feet after t seconds is given by the function, and then we're asked 4 different questions about it. So what I did on my graphing calculator is that I went to y equals, put in the equation that was given, and found a few points so I can graph it on my graph paper. So I've got 0, 4, so about right here, to 36, so 36 would be about there, 1.540, Mm-hmm. 40, and then 3.10. So that is our graph here. And if you choose a different scale for your x and y axis, your graph may look a little bit different. In your calculator, it may look a little bit different because I chose to count by 0.5 and count by 5s on the y-axis. So if you or your calculator choose a different scale, it is going to look different, but it's okay. So with a ball being thrown, so in red, I'm going to show you how this is going. We are at 0 seconds and 4 feet above the ground. This ball is going to be thrown up, and then it's going to end up going down. Anything goes up must come down. So it's going to go all the way up, then it's going to come all the way down. So if it follows this trend that is shown in the graph, what height will the ball be when 2 seconds has passed? Well, again, 0 seconds, 4 feet above the ground. So 0 seconds is shown in our x values. Our 4 feet is our y values. So at 2 seconds, we are at 36 feet. And how many seconds will the ball reach its maximum height? Well, you can see it on the graph. The max height is found at 40. Well, it asks, how many seconds will it reach that? Well, with our x being our time, we're looking at 1.5 seconds. What is the ball's max height? We just spoke about it. It is 40 feet. Then when will the ball hit the ground? Well, if the ball hits the ground, so we're looking at being thrown up and then coming back down. We're looking at this point here, which is roughly about 3.1 seconds. So that is the answers for Unit 1's quick review.